need an on-air button. On-air sign. And that doesn't mean you guys, now if you're talking, don't talk like around the camera because it'll pick up, I think Brock said that's what she said. During one of I was talking to the wrong vector, and of course Brock had to say that. So I got picked up on the video. I have to edit that out. But my nephews watch this. Come on. Just around the camera, be careful what you're whispering. Okay, so we're going to look at number 5, 5A, and I can't call it. This is actually, I got to title this thing Investigation 7 Expansion, and this is part 6. Okay, and so we're looking at 5, and I have I'll kind of go quickly through it. We've got Eskimo Joe here is dragging a sled full of supplies across the snow. I'll read it to you at home in case you don't have this with you. The sled, along with supplies, has a combined weight of 1,800 newtons. The sled snow contact produces frictional force of 400 newtons. Joe's pulling the force with 750 newtons on a rope attached to the sled at 20 degrees. So all these numbers, and this is why you have to have a good free body diagram. It's not just because Askey makes you do it. It's because it's good for you got to help you understand the problem. So there's a center of mass. Right now we're calling everything a dot. Now in April we'll start to call them extended objects. We'll give them direction because then they're going to start to twist and rotate. And then you have to talk about torque. So until we talk about torque, we can make everything a center of mass. So here we go. Well, it's going to have, you guys, what 4 forces are on there? You guys can help me. We've got mg, normal, and so we're going to have mg, we're going to have normal. Now, will mg and normal be equal?
Yes.
Yes. Be careful. Sometimes they are, but not all the time. We'll see. Maybe they are. What else do we got?
We have friction.
We have friction back, and that's going to always oppose motion, so it's supposed to be straight back. There's my F sub, and where it's sliding friction, so it's F sub K. And the DOM is this way.
F sub P.
And so we also have F sub P. Now what about F sub P?
It's long.
It has to be longer, but what is that? There's any kind of angles involved.
20 degrees.
So we have to make it really long because we're only getting a component of it. So something like that, and that's my force of pull. And then dot, 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 there's 20 degrees. So you should spend a little bit of time on your free body because it can help you a lot. This, I can also write some numbers here. That's 1,800 newtons. I guess it gave me that. Yeah, 1,800 newtons. And this is 750 newtons. And what else do we have? 400 newtons of frictional force.
That's awesome.
And the normal force, I don't care. I mean, it's there, but I don't care what the force is unless it comes into play. Okay, so we got everything we need. And I can hear Austin coming. All right, so A. So A is, it asks, what is Joe and the sled's acceleration? So where do I start?
Summation of forces equals mass times acceleration.
Summation of force in the x equals max. So when in doubt on the quiz or test, once you draw the free body, just slap that on there. That's probably the second move until we become more sophisticated. We'll work our way from force up to energy, and then we'll be much broader. We can attack a lot of different kinds of problems. Ultimately, we'll get to what's called the ultimate fighting tool, and we can attack a lot of problems with that. All right, so only in the x direction. So it looks like normal is not going to play a role here, neither is mg, because they're in the y direction. So I have, now the next thing is to go ahead and break this up and say what forces I have. I have FP, now what do? Cosine or sine? Always cosine, and it's a right triangle. Every vector at an angle is a right triangle. And so every vector at an angle is a hypotenuse of a right triangle. So I have FP cosine 20 minus what? FK. See, I'm putting my I can't, there's no reason to put, okay, you tell me, why would it be dumb, or not dumb, but redundant to put a negative 400 right there? Why is that redundant?
Well, it's already.
because I'm showing the direction already. Now the problem is, in an equation you can't. You have to say negative 400 or negative FK because I can't show direction
Mr.
otherwise.
Askey,
Yeah.
Is friction ever positive?
Only occasionally static friction can be. If static friction is helping motion, it can be. It can be if static friction is helping motion, it can be positive. But kinetic friction can never. If you ever have kinetic friction, there's no case. It's impossible for kinetic friction to help motion. You watch somebody find a way it can, but I've never seen it. Never in my class anyway. So there's my equation, and so I'm trying to solve for a sub x. So I can go ahead and just, I guess, do it symbol-wise. It's probably a good idea. So a sub x, then I'll bring it over here, is fp cosine, I could say theta, I'll go ahead and say 20, minus fk divided by m. So you're going to get right there, if you left it like that, and sometimes problems on tests, it's as far as you go. That's all you got to do is show the symbols. You would get some pretty good credit by knowing that much. Now it's just plug and chug time. So a sub x then is fp cosine theta, so we're looking at 750 times cosine of 20. All that is going to be newtons, minus fk, that's 400 newtons, divided by my mass, which, I don't know my mass.
It's 1800 divided by 9.
Okay, so 1800, go and do that. 1800 newtons divided by 9.81, the old magic triangle.
What's it divided by?
T. Rich hates so much. You divide it by gravity, because the magic triangle on your equation sheet says, put your hand over that, and you're going to divide mass mg by g, and you'll get the mass out. Okay, so you plug, and I'll do a little Martha Stewart or Julia Child, if you're old enough to remember that. And I'll pull it out of the oven now. It's already cooked, and the answer is 1.7 meters per second squared. So, ta-da, there's 5A. This is number 5, by the way. All right, so 5A. Questions on that before we rapidly go on to B? Bell's about to ring. I'll
If
tell
you
you
can
what.
only keep it up for
Let's
12
pause.
seconds, then it's just, you just do...
Yeah, so the rest of it, a lot of the rest of it's kinematics.
Right?
So I'm going to pause this, let you guys... Okay, I don't... that was the main, 5A was the main thing I wanted to show you, and I know the lights are on, you can't see that well, but 5B, 5C, 5D, 5E, all of that, all of that comes, really, that's really kinematics, okay? The F equals ma part, the free body part, that's all good. And 5B is like second orange mirror, you can just plug and chug at that point, you can do that. 5C is third orange, so that shouldn't be the big problem. 5D's got a little bit more that you might. You looking at 5D, it says the force is reduced to 425.671109 newtons. Why would I make that crazy number? And if you look at it and check out cosine 20 and see why that number would pop up. And why that's an important number to have. And really 5D is a conceptual question. You can take some number crunching, but it is a F equals ma question. But it's a summation of forces. You got to go to it. Okay. It's a summation of forces, and I don't want to say too much more, but it also it's a question about inertia. So I'm asking you what's going to happen if I reduce the force down to that, or if Eskimo Joe reduces the force down to that, what will happen to the sled? And then finally 5E, once you figure out 5D, then if he keeps this up for 15 seconds, how far will he go? Well, that's a real simple, very, very simple question. Okay, so I'm going to, rather than waste the computer space and your time, I'll let you work through 5D. The answers for 5B through 5A should be on your sheet. Okay, so good luck. Thank you.